In this video, we will look at a program which is based on the concept of pointers. In this program, we will point a pointer to an array. Means till now we have seen how we can use pointers to simple variables. For example, we know how to declare a pointer to an integer. Suppose we have an integer a whose value is 5. Then we can have a pointer by initializing it. We can write int star p, and next line we can write p is equal to ampersand a. Or in the same line, we can write it this way, int star p is equal to ampersand a. So p will point to the variable a, and using p you can access the variable a. Right, in the previous video of pointers, we have seen how we can use pointers in a program. Now in this video, we are not going to point this pointer to a simple integer variable or a float variable or a character variable, but this time we will point the pointer to an array, that is a collection of elements. So as you can see in this program, we have first included the header file, and in this program we are going to reverse the list of elements. For example, if we have an array ARR of 5 and it has been initialized with maximum it can have 5 elements. Suppose 2, 4, 10, -1, 6. So if I want to reverse this particular array, then the output of the reversed array should be 6, -1, 10, 4, and 2. So we know different ways to reverse the array, but this time we are going to do the reversing with the help of a pointer. So include the header file, then use this macro constant by writing #define n and 5. Means wherever you use capital N in your program, it will get replaced with its value, which is 5. So in the main function, we have declared the array by writing int a of n. So whenever we declare this int a of n, what will happen is n will get replaced with 5. So you can read it as int a of 5. Okay, wherever n is there, 5 comes. Next, we have declared the pointer to an integer. Okay, for now we have declared it as a pointer to an integer by writing int asterisk p. So this is a pointer declared to an integer. Later on we will make it as a pointer to an array of integers. Okay. Next line, we are telling that enter these many number of elements in the array. So we are displaying at the output that we are telling the user enter elements in the array. How many elements? We have written %d means the value of n will come in place of %d. N is currently 5, so it is like telling enter 5 elements in the array. Okay, so now you can visualize the array. Because we are going to store 5 elements, n is equal to 5. So you can visualize the array like this. Suppose there are 5 spaces in the array, you can store 5 elements. And what is the starting address of the array? 1000. So 1000 is also called as base address of the array or starting address of the array. And the address of the first element of the array means address of a of 0 element is same as the address of the array, right? Wherever the address of the array begins, at that point you will store the first element of the array. Means the address of the first element of the array is nothing but the address of the complete array, base address of the array. We know this already. Suppose this is an integer array, then each element in the array will occupy 4 bytes because integer value occupies 4 bytes. That is why the first address is 1000. Suppose you store the value 6 here, integer value 6. So this value 6 will occupy 4 bytes in memory because 6 is an integer. So the next value of the array, suppose it is 4, then it will get stored from 1004, right? So at 1000, at the address 1000, at the address 1001, at the address 1002, up to 1003. All these 4 locations will be occupied by the integer value 6. So I'm saying that from the address 1004 onwards up to 1007, you can store the next integer a of 1. Okay, a of 1 is 4 in this case. Then you can store the next integer at 1008. So consider multiples of 4. First base address, starting address is 1000, then 1004, then 1008, then 1012, and 1016. Okay. Now, consider this for loop over here. This for loop. Using this for loop, we will accept the elements from the user. We have to accept 5 elements. So initially, I have written what is the first initialization condition of the for loop. We have written p is equal to a. P is a pointer variable. If you write p is equal to a, or even if you write p is equal to ampersand of a, where a is an array, okay? If you don't write ampersand for array name or string name, it is fine. I have told this multiple times. So you're pointing the pointer p to an array, and this array can store integers, okay? So initially p is equal to a. So consider p is a pointer and it is pointing to a, means initially it will point to the first location within the array. That is the position of the first element of the array. P is pointing to this one. So if P is pointing to the first element in the array, what will be the value of P? P is a pointer using which you can access the elements of the array. But what is the value of P? The value of P is the address of the element to which it is pointing. Now it is pointing to the element a of 0, right? At the first position, we are storing the element a of 0. So what is the address of the element a of 0? 1000. So the value of the pointer will be the address to which it points. P is pointing to a of 0. So the value of pointer is the address of a of 0. So the value of pointer is 1000. So if I print P, the value 1000 will get displayed. But suppose I print asterisk of P, means you can access the value at 1000. So suppose the value 6 is present at the address 1000. By the help of asterisk P, you can print out the value 6. Right? We have seen this before. Now, initially pointer is pointing to a of 0 element. By which statement? By writing P is equal to a. Now next, what condition will be checked in the for loop? This condition, middle condition, whether P is less than or equal to, whether P is less than or equal to a plus n minus 1. So now initially when P is equal to a, it is like saying that the value of P is equal to 1000, right? Just now I showed you that if P is pointing to the a, or if P is pointing to a of 0, means it is pointing to the first element. So its value will be address of the first element. That is, the value of P is 1000. So I have replaced the value 1000 for understanding purpose. I have written P equal to a. It is nothing but P is equal to 1000. Now next, what condition will be checked? P less than equal to a. Currently, what we have done, a, if I'm writing P is equal to a, means P is equal to 1000. So here also a is there. So you can say that P less than equal to 1000 plus, what is the value of n? 5 minus 1. Now, whenever you do addition or subtraction with respect to pointers, for example, if I write p plus plus, it is like saying p is equal to p plus 1, right, post increment, and p plus 1. How will this happen? As I mentioned earlier, since p is a pointer to an integer, so whenever you do plus 1, it will get incremented by the size of an integer. So integer occupies 4 bytes. So if I'm doing p is equal to p plus 1, it means the current value of p is 1000. And when I do plus 1, it is like doing 1 into 4. Okay. It is like doing 1 into 4. Because each time you increment p, it should get incremented by the size of an integer. So each time you increment p, it should get incremented by 4 bytes. So even if you write p is equal to p plus 1, it is what happens internally, it becomes p plus 1 into 4. Suppose I write p is equal to p plus 2. Then internally how it will happen is, currently the value of p is 1000. And then what I'm doing? I'm doing plus 2. 2 means it will happen like 2 into 4. So what will be the answer? 1000 plus 2 into 4 is 8. So 1008 will be the answer, right? So initially p is pointing to this 1000. P is pointing to this 1000 as the element. Address 1000 it is pointing to. Once I do p plus 2, what will happen? Plus 2, so it will go to the element at 1004 and then it will jump to the element at 1008. So this is how you are going to access the array elements. Okay, I repeat. If I do p is equal to p plus 1, what will happen? It will become equal to 1000 plus 1 into 4. So it will become 1004. So initially p was pointing to this address 1000. Now I have incremented by 1, so it is pointing to the address 1004 so that I can access the second element of the array. Now p is pointing to this 1004 address. Now again if I do p is equal to p plus 1, what will happen? Now the value of p is 1004. And if I do plus 1, it is like plus 1 into 4. So now 1004 plus 4. So it will become 1008. So now p pointer will get incremented such that it is pointing to the third element, because third element is stored from the address 1008. So this way, whenever I do plus 1, how the address is getting changed so that you can access the elements one by one. Right? This was for the example of integer. Suppose the example was you have a character array. So it is a array which stores characters. Then by what you would increment? If I do p is equal to p plus 1, means initially if p is 1000, 1000 plus 1 into 1. Why 1 into 1? Because plus 1 means 1 and into 1 because character occupies 1 byte. Right? So if you're doing plus 1 over here, you must consider it to be plus 1 into size of the data type. Okay, size of the data type. So the general formula is, whenever you do p is equal to p plus n, it means you're writing p plus, internally how it happens, p plus n into size of data type. And this is the formula using which the compiler can internally increment your pointer so that you can access the elements one by one from the array. So I hope you understood this. So now initially p is 1000. And what is my termination condition of the for loop? I'm doing a plus n minus 1. A is what? If I write p is equal to a, means starting address of the array. So I'm checking p is less than equal to 1000 plus 5 minus 1. But we have seen whenever we do p is equal to p plus something, it is like saying p plus something into size. That is why now you consider this is the starting address and this is 5 minus 1, it is n suppose. So now you are checking p is less than equal to a plus n. Okay, consider this. Suppose 1000, in place of 1000 you are writing a, and in place of 5 minus 1 you are writing small n. So it is like saying less than equal to 1000 plus n into size. Okay, plus n into size. But here what is the value of n? 5 minus 1, that is 4. So if I write 4 over here, then 4 into size. Size is what? 4. Okay. So less than equal to 1000 plus 4 into 4 is 16. So 1016 this will become. So termination condition becomes p less than equal to 1016. And 1016 is what? Till here. 1016. So 1000 to 1016. P is less than equal to 1016. This is the termination condition. Okay, let us see the termination condition once again. So P is less than equal to A plus n minus 1. And what is the value of A? Value of A is initially 1000 plus, whenever you do plus anything, in this case plus n minus 1. N minus 1 is 4. So it is like saying P plus 4, and whenever you do plus anything, you must multiply by the size. Size in this case is 4 for integer. So it will become 1016. Right, so this is how we get the termination condition. So it will start from the address 1000 and it will go up to the address 1016. Okay, so that's what we understood from here. Now this is the initialization condition and this is the termination condition. Now we will continue. Now we have checked the initialization condition and we have checked the termination condition. Now when you do plus plus, you will be able to increment one by one so that you can access each element of the array. Now p plus plus. So we can access one by one the elements, right? Whenever we do plus by 1, we have to multiply the size, right? We have seen. So now we understood how this for loop will run. Okay, I hope you have understood. And how we are going to store the elements? Scanf is equal to %d and p. Now whenever we write p, it means address, right? If I'm printing the value of p, means the value of p is an address. Address of what? Address to the element to which it is pointing. So whenever you write scanf, we write scanf, then we write %d, we write comma and ampersand variable name, right? Ampersand variable name means address. So here p is giving us the address directly. So that is why we are writing p over here, so that we get the address at which we want to store the element which the user will enter from the keyboard. So initially p is 1000. So whatever the element the user will enter at the output window through the keyboard, it will get stored at address 1000. And 1000 is what? Indirectly, you can say that 1000 means nothing but ampersand of a of 0, right? So initially, if I write P here, it is pointing to the first element of the array. So it is like saying ampersand a of 0, right? That is what I've written over here. So first P is pointing to a of 0. So you'll accept P. Then what will happen? P plus plus. If P plus plus happens, it is equivalent to saying P is equal to P plus 1. So when I do P plus 1, it is like saying P plus 1 into 4. That is, initially P is 1000, so it will become 1004. So now P is equal to 1004. So at this address, you will be able to store the next element. Again, you do P plus plus. This time when you do P plus plus, the address will become 1008. So you can store the next element at 1008. Next, you will be able to store the element at 1012 and then at 1016. And we know termination condition is 1016. So as soon as P becomes equal to 1016, and then you do P plus plus, then the next time the for loop will get terminated, right? So we have accepted all the elements in the array. Suppose these elements have been entered by the user 10, 20, 30, 40, 50. Now what we will do? We are going to print the message. The elements in the reverse order are, okay? So we can print out the elements. Now we will again run the for loop. This time how we will run the for loop? We want to reverse the elements. So we have to start from the last element and go up to the first element. So we have to just change the position of the pointer. When we had to accept the elements, we started from the first position and we went up to the last position. This way. But when we want to reverse the elements, we have to start from the last position and go up to where? We have to stop over here at the first position. So we are going from right to left. So initially, you have to initialize your pointer to the last element, right? You have to initialize your pointer to the last element. So how we have to do? Last element means it is actually the termination condition, right? It means in the first for loop, the termination condition was 1006 in this particular for loop. Means we had to terminate at the last position, at the position a of n minus 1, right? So the same condition we have to use now. So where we had stopped in the first for loop, from there we have to start, right? Where we had stopped in the first for loop, we had stopped at this position. So now we have to start from this particular position. So the termination condition of the first for loop, which was a plus n minus 1, becomes the initialization condition of the second for loop. As you can see here, this is my for loop 1 and this is my for loop 2, right? So you have to stop over here in the first for loop, which is the last element position, and you have to start from the last element position in your second for loop. Now where you have to stop in case of your first, where you have to stop in case of your second for loop, you have to stop in case of your second for loop at the a of 0 position. That means the initialization condition of the first for loop becomes the termination condition of the second for loop, right? This is the first position initialization and this will become the termination of the second for loop, right? So now let us see what happens. Now if we have to traverse the second for loop. Now if we are going for the second for loop, let us traverse it. So we have to start at the address P is equal to a plus n minus 1. So now a plus n minus 1, we have solved this already. We are getting the address as 1016, right? So this condition will be checked now whether 1016, we have to check this condition, whether 1016 is greater than equal to a. A means what? The base address of the array, that is 1000. Condition satisfied. So you will execute the body of the for loop. What you have to do in the body of the for loop is you have to print asterisk p. So now the value of p is what? 1016. and asterisk p means you will be able to get the value at this address. What is the value at the address 1016? The element 50, right? We have filled the array 10, 20, 30, and 40, and 50. So the value at the address 1016 is 50. So that we'll be able to print as 50 over here for the first time. Okay. So we have accessed the element at the position a of n minus 1. Now what we'll do, we'll decrement the pointer p minus minus. So saying p minus minus is nothing but p is equal to p minus 1. P is equal to p minus 1 means initially what is the value of p now? It is 1016. And whenever you do minus or plus, what you have to do? Minus 1 means minus 1 into size of the data type of the array, that is int means 4. So 1016 minus 4 means 1012. So now p is pointing to the second last element's position 1012. Now when I do asterisk p, so I will be able to access the value at this address 1012. What is the element at the address 1012? The element 40. So I get to print the second last element, which is the value 40. Similarly, I'll keep on decrementing, and finally I'll reach the value 1000 as the address. So when p becomes 1000, this condition will fail, okay, for the next time, and you'll terminate, right? So when you're accepting the elements, the condition was displaying the elements in the reverse order. Suppose you will use the termination condition of the first array as initialization, and initialization condition of the first array as the termination for the second array. So I hope you understood. Suppose you had to print the elements as it is, not in the reverse order. Then you had to make some changes in the second for loop, right? So if you want to display the elements from the start up to the end in the ascending order, means first you want to display a of 0, then you want to display a of 1, then you want to display a of 2, and so on. Means as they have been stored, you want to display them. Then what you would have to do? You will use the same initial for loop. The for loop 1 only you would have to use, right? So the for loop 2 would be p is equal to a semicolon p less than equal to a plus n minus 1 and p plus plus. Okay, p plus plus, why? Because you have to start from the 0th index and go up to the n minus 1th index, right? So this is how you can reverse the elements. I hope you have understood how to access the array elements using pointers. So the output finally would be the reverse in this case if we are printing in reverse order. So first 50 would get printed, then 40, then 30, then 20, and finally 10. Okay, you can see the output here. So that's all for this presentation. So you can practice how to point the pointer to an array, and you can do different operations, right? This example, what we did, we were able to access the elements and print them. In the next program, maybe you can access the elements and find out the sum of the elements using the pointer concept, right? So you can try out such programs on your own. Thank you for watching this video.